recorded. Okay, we missed to record. Okay, so see, today we're talking about operators in SQL, right? And these are the things that we discussed. We discussed about negation, okay, identity. Now, when we don't provide anything, like for example, salary, right? So salary, we're looking for positive salaries only, but you can make it negative using negation, right? So that's the, and it takes the highest priority. So if you have a query which has multiple of all these, right? If you have multiple of all these, so first you have to look at the negation, right? So minus salary, you have to look first before minus salary less than 0. So if you have to evaluate, okay, before, like, see, there are two ways you can evaluate, right? Salary less than 0, and then you put minus there, okay? But no, always negation or identity will take first preference. So first you will convert salary into minus, right? So when you convert salary into minus, 1800 will become minus 1800, okay? 2000 will become minus 2000. So that's why 1800 less than 0, okay, will hold true, and you will get entire list, correct? Then we went to multiplication. So in this example, what we did, we wanted to calculate annual salary. So we took salary, we multiplied by 12, okay, and we are renaming it as annual salary, correct? So alias to the column that we are giving. So when you run this, you get first name, last name, and modified salary, which is salary into 12. So this is how you can apply multiplication in the column values, just like you do to any number. So after negation, multiplication is takes the next preference. Okay, so even if I had a condition here, first you'll perform this on the entire column, then you will look for where clause. Okay, so first priority is your negation, second priority is your multiplication division. Okay, third priority is for addition, subtraction, and concatenation, right? So here you have concatenation. We are using addition here. So in this case, we are doing addition plus multiplication both. So first multiplication will be done, and then this will be added to this one. So here you have two operations, just like mathematics. Okay, so first multiplication will take preference over addition. So you have salary plus salary into. Now earlier, okay, now okay, I can copy this and paste it. And when we did not do this part, right, and we directly multiplied commission. So now when you run this, what did we get? Can somebody tell me before we get the output? Total salary was 0, right? Total salary was 0, even though we have a salary value, because commission percentage is null. Okay, and I told you null is not same as 0. So null into a number will be a null only, right? Okay, because 5 into 0 is 0, but 5 into null is like, I don't know what you are doing. It's like I'm clueless. I don't know what you are doing. So the result was null only. So next step, what we're doing using coalesce, we are saying that if commission percentage is null, this is what this function will do. This will check the value here, and if this is null, it will replace with a value that we give. 0. So in this case, we are giving 0. If you want to give 100, 5,000, up to you. So I'm saying if commission percentage is 0, then, sorry, if commission percentage is null, then make it to 0. So for the step calculation, we are making it to 0. And when you run it, you get value. So since commission percentage is null, it is treating as 0, and you get the same salary. But where it is not null, yeah, you get a different, you get a, the calculated value here, which is commission percentage into salary plus salary, right?
Okay. So works for only null values?
Yes, coalesce is only for null values.
Okay, whatever number we have mentioned, it will replace with null.
No, 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 no.
I
It
mean,
will
you have
replace
given
null with whatever value, yes.
previously. Okay.
Yeah.
What number we have
Yeah.
given?
Yeah. Okay. Then we go to what we call as comparison operators, right? So once we are done with okay, so multiplication, then comes your plus, minus, and concatenation. Plus, minus, concatenation takes 1, 2, 3, third preference, right? After your multiplication, that's the third preference. So see, preference comes when you have multiple things in same query. Then which one will be evaluated first, right? So follow this rule. Okay, first negation, then multiplication, then addition. After that comes your comparison operators. Equal to, greater than. Okay, we have already seen equal to, greater than, right? And not equal to is this exclamation mark, which is shift 1, right? Your keyboard 1 has this exclamation mark, and equal to is not equal to. So if I say star, select star from employees where salary not equal to 1500, that means it'll give us all the record which does not have salary 1500. So everything except 1500 is what we get, right? So that's how we can select in the where clause. So comparison operators will always come in where clause. Comparison operators will always come in where clause. So in where only we are comparing the values. So all these things that you see, equal to, not equal to, less than, greater than, less than, equal to, greater than, equal to, is, null, like, between, in, all these will be after where. So here we are using and, between. So between always comes with and we use it only on numbers. Okay, so between 5,000 and 10,000 is like saying where salary is greater than 5,000 and salary is less than 10,000. So instead of, if you have same column, right, like salary, so instead of using salary greater than and salary less than, you can simply say between. Between is always inclusive. Okay, so it will include salary with 5,000 and 10,000. So between is inclusive. Okay, so if you have 5,000, it's like saying greater than, equal to. Okay, so between is like saying greater than, equal to, and less than, equal to, not greater than, sorry, greater than, equal to, and less than, equal to. This is what between means. You can use in also. Okay, so between takes two ranges, minimum range and maximum range. But in, you can have as many values as possible. So here you are not doing range. You are actually giving specific values. I want all the information where employee belongs to IT Prog and ADVP roles only. So you are giving specific roles. So mostly these are used for with text, okay, but you can use it for numbers also. When you are not able to form a range, right? If you are able to form a range, between. If you're not able to form a range, if between 10 to 50, you have 10, 30, and 50, but you are ignoring 20 and 40. Then in is best, okay? But anything which is multi comparison, right, is slow. So if you look at performance, okay, performance of between is faster than performance of in. Okay, so as much as possible, if you can use between, use between. Okay, but if you can't use, right, not that. So if that was all the case, then we wouldn't have created in option, right? So where you cannot use anything else, if in is the only option, you use in. But preferably, okay, we prefer between than in.
Swapnil, what do you
Yes.
mean by performance? Like performance of between?
Performance with the number of the time that it takes to give you the result.
Oh,
Okay. So in SQL, performance always means the time. Okay. Now, when you have 10 million record, okay, then you can visibly see the difference. Okay. So, here we always talk about time. Okay. Maybe with 100, 200, 1,000, 5,000, 10,000 record, you won't see much difference. But as you increase your data, right, on if the table size is larger, time taken will be more, isn't it? So
yeah, but as you said, if we have to pull up a record of a particular like department ID, like only 90, so then in will be the only option we have, right?
no. If it is 90, then say equal to, no.
Oh, yeah.
Right. So equal to will be
Yeah.
faster than in, because in it's like this. Okay. So I give this example. Let's say, you have a one-way road versus two-way road, right? If you have a one-way road where you don't expect any vehicles to come from opposite direction, your speed will be comparatively faster, is it not? Than two-way, because you're expecting that some, vehicles can come in front of you. So when you say in, even though you're giving only one value or you're giving only two values, okay, but because of in, your query will be slower because, it will take one value, then it will take second value, then third value. But when you say equal to or greater than, it knows that, okay, I don't have to check for anything else. Okay, the performance actually improves. Okay?
Yeah, understand. Thank you.
Sure.
And also, Swapnil, in between, like we can use only numbers, right? We can't use
Yes,
text.
yes. So that's why text performance is always slower than numbers. Okay, so we try to do, whenever you are trying to do where clause, right? Where, okay, try to use numbers as much as possible. So in this case, we have option to use job ID or say department ID. Let's assume that both are different, so they cannot replace each other. But let's assume you had an option either to use department ID or job ID. Then prefer department ID. Okay. Numbers are, because numbers, are easy to compare than text. Okay. Because if you have to compare numbers, right, at even position, you have only 9 values to, or 10 values, 0 to 9 to look for. But in text, you have like 26 plus 26, 52 values to check. Right?
Yeah,
Capital, small. Yes, smaller letter and capital letters are different in text.
Okay.
Okay.
And it also takes time to execute the query also. Maybe.
Exactly. Okay. It is longer, right? So that's why, as much as possible, use numbers, okay, in where clause.
Okay.
Okay. So yeah, you can use it for both numbers and text, not a problem, or even for date. Okay. So date, until unless we specifically mention,
And
you treat date as a text only. Okay. So if performance of date is again faster compared to text. Okay. So, okay. But like in and other things, it is, we treat it as like when you say text, it means date also. Okay.
And also in between, like 5,000 and 10,000, you said, right? Like 4 numbers we can't give, right? Like,
no, between is always A and B.
okay.
Between A and B. You cannot say between A, B, and C.
Multiple values use in, right? Like multiple, more
Yeah.
than 2.
So you can say and greater than and. So that and is you're adding query. Okay, just like we have done somewhere here, right? Okay.
That means we
Percentage is not null, and this and this and this. You can keep on building multiple where clause. Where clause will not have one. In fact, multiple clause will always have. So you give one condition and another condition and one more condition, or and or you can use to create your outcome. So your query will not have only one condition. Like see the last one that we did, right? So we have two conditions here. We are saying commission percentage is not null. This is one condition, and employee department equal to department.
that's fine. Like in between, like I was like,
How can you say in between? Between 10 to 20 to 30 is same as 10 to 30, no? Right?
okay.
10 to 20 to 30 is same as 10 to 30, correct? But if you want to say 10 to 50 and 100 to 200, it becomes two different between. Between 10 to 50 and between 100 and 200.
Okay.
Okay. So now, okay. So in we did. Now, yeah. So I was saying that when you have in, you can give specific values, or you can even use. Sorry. You can even use subquery, right? So how to write subquery? So query inside a query is subquery. So let's say I have written a query, simple query here, where select department ID, where department, from department, where location ID in 1700, 1800, 1500. So if you run this, these are department ID that we are getting. Now we are giving same query, okay, exact same query inside the previous query. So I'm selecting data from employees and then saying where department ID in, okay, department ID in, and then I'm selecting. So, you know, if somebody says that, tell me the employee who are in this department and which department is located in 3 location, 1500, 1800, 1700 location. Okay. So in that case, you know, you can write this way. Okay. And this will also give you perfect result. But what we said was subqueries are not preferred. There are situations, there are some very difficult situations or conditions where you will have to give subqueries. Okay. There are situations where you have to give subqueries, but not always subqueries. In terms of performance, some subqueries are not preferred. Okay. So when you are doing performance tuning, when you're looking at performance, first thing that we do, and which will solve 70 to 80% of problem, is create an index. Okay, and we are not talking about index, we'll talk about index. Okay, so that's the first place that you have to look for, index. Okay, creating index will improve your performance. Second biggest performance opportunity is converting subqueries to normal query, single query. Okay, the developer might put subquery because the developer at that point of time may not think how to do it. Okay, might put subqueries, but later when you get a problem, when you test it, or customer complains that this query is slow, and you see it's a subquery, okay, there is opportunity to, okay, convert it. Of course, if you cannot, right, not every time it can be converted, then you don't. But this is the second biggest, okay, uh, uh, what do you call, culprit for your performance problems. Okay, so convert subqueries into queries like this. So we just converted same query into like this. So here, first time we are getting data from 2 different tables. So remember this, if you are getting data from 2 different tables, okay, and if you do not have a foreign key relationship, you will get m into n kind of data, right? M is the number of rows coming from first table, n is the number of rows coming from the second table. So output will be m into n kind of uh, relationship, okay, or total record. That means if I say select the first name from employees, and if this gives me 50 and location is giving me 10, you end up getting 50 into 10, 500. So whenever, okay, this blindly, you can say that whenever you are joining 2 tables, okay, you need to add this, where first table foreign key equal to second table employee, primary key. You'll always have to do this. You can join 3 tables, 4 tables, 5 tables. If you're joining 5 tables, you will end up creating 5 where clauses minimum, where table 1 dot foreign key equal to table 2 dot primary key, comma, table 2 to table 3, table 3 to table 4, table 4 to table 5. You will end up linking those tables. Okay, so whenever you have, okay, from 2 different tables, you should have a where clause where you are connecting them on the common column. Name could be different. Okay, here luckily it is department underscore ID. It could be DID or department ID. Okay, so if DID is in employee, so you will say emp.did equal to department.department ID, right? But there has to be one column. Okay, and this is where now you see the importance of foreign key. Okay, if we had not created foreign key, okay, now here see it does not check. Okay, it does not check, it doesn't have to be foreign key. Okay, you may end up creating tables, okay, where you do not link them as foreign key and primary key. Foreign key and primary key will be helpful. Okay, especially foreign keys are helpful when you are trying to add some incorrect data. So let's say department ID 50 is not there and you are trying to add an employee to 50. So if you have the foreign key relationship, it will give you warning saying that corresponding value not available in department table, right? So you know that you're trying to enter something wrong. Otherwise, this will work even if you do not create foreign key primary key relation, because it's checking the values from both the table and giving you the result. Okay, so this is the importance. Okay, you need to add this where clause where you're comparing the common column between 2 tables. So now it will do a match. It will perform a match, okay, of first name, last name, even though we are not using department, it will take the department of this, and if both are same only, you will get it. Make sense?
I am not understanding it. And I also have one question. So
Hold on.
yeah.
If you're not understanding, let me make you understand, then we'll get your question. Okay. Now, let's say you have your table A, B, and C, and you have department ID 10. Okay. You have another table A, B. Okay, let write C. Okay. We'll just have first name, last name, right? So first name is A, last name is B, department ID is 10. You have C, D, and department is 20. Okay. Now in this table, you have location ID 1, department 10, location ID 2, department 20, location ID 3, department 30. Now, if I do not give this query, okay, I'm not saying the department ID should match. What it will create, it will give me a result, which is 2 into 3, 6. So you will get A, B, 10, 1. Okay, A, B, 10, 2. A, B, 10, 3. Now you will get C, D, 21. C, D, 22. C, D, 23. This is the output you get if you do not put where clause. Okay, because it doesn't know that this 10 and this 10 has to match. Now, if you put where clause, it will match department employee 10 with department 10. Okay, so if only there is a match, you will get. So in this case, the output will be A, B, 10, 1.
10 and 1.
Yeah.
10.
Okay, C, D, 20 and 2. This is so actual output will be these two record, which is correct. But if you do not give where clause, you will end up getting 3 into 6. Imagine, I've just given 2 examples. But if you have thousands and thousands, you'll get into millions and millions, right? So that's why we have to give where clause when you're comparing or joining data from 2 table. So see, first name, last name, location ID, this is clearly in first table. Okay, this is clearly in first table. This is clearly in second table. But let's say I want to display department ID also here. Now, even though it doesn't matter from which table the data picks, right, for us, but for SQL, it is confusing, right? I have department in both the table. Employee also department. Which table you want? So you will say, I want it from employee. So EMP dot. So, okay. So if there is a common column which are repeated in multiple tables, you have to specifically mention from which table to pick. It doesn't matter for output. Okay. The value will be same. But as a, SQL will get confused because there are 2 options. Which one to take? So I'm saying take from EMP data. Whether you take from EMP data or you take from department table doesn't matter. Okay. Output will be same. But you have to clear the confusion, right? So then you say employee department ID. Now when you run it, you get what we got 34 something, right? 34 rows only, yeah. Okay, so see, it's all 80, 80, 80. Is it correct? Okay, so if I run this, is it only 80 department number? No, all these, right? Okay, so maybe, see here you have all these, correct? 50. But here when we run, we got only 80. Is it the this doesn't have employee?
Maybe in other table department ID like only 80.
No, we said commission percentage is not null, right? Commission percentage is not null. Only sales department will have not null. So that's why you're getting 80. 80 is your sales department. So definitely if you say select staff from department, okay, you will get 80 for sales. 80 is sales, see? Because we said commission percent is not null, right? So commission percentage is not null only for sales. Everybody else has a commission of null. So that's why only 80 we got. If you remove this, then you get more, obviously, right? If you just remove this, commission percent not null and now when you run it, you get a lot more, right? Obviously.
Okay.
Yes. Now tell me a question.
Yeah, like in this last query you have written, can you please go to, yeah. So after HR employs EMP and HR departments DEPT. So EMPT and DEPT, I mean, this
Alias.
is not, oh,
Alias,
that was
right?
alias.
Yeah.
Okay.
That's what we did here, right? Salary to 12 space name alias. So this is column alias. This is table alias. Another name for the table.
Okay. Okay.
Now, okay, you may not have to do this. You may not have to give employee. Okay, let's say you don't give alias. Then what happens? Then when it's a department ID, right? It will not know which department ID from which table are you talking about. Then I have to copy and paste entire stuff, right? HR.employees. Okay, so HR.employees. Already you have HR.employees. That will create confusion. Okay, it will not know that it is schema and this is database. One. And second thing is you have to write such a big table name everywhere. So it's better that you give a easy
Alias
to
name.
alias name, which is easy and makes sense here, because schema name dot table name dot again will create confusion for it. And then anyway, you have to type such a big thing. Okay. So always you will see that when you are combining tables, okay, give an alias. That's opportunity for you to use less number of text, right? Use that and you do it. Now see, we could have done alias here also, right? But we don't need to give, because there's no confusion here. So why to write extra text? You can write alias here and say emp dot first name, but there is no need, right? Why to write extra? But when you have multiple tables and columns can repeat in same column can repeat in different table, okay, you have to give. Now let's say employee had DID, let's say, and department had department ID, and both are linked as foreign key. In that case, you don't have to give alias, because computer will not have, SQL will not have any confusion. Okay, because
Mhm.
DID is from employee and department ID is from department. So in that case, alias is not required at all. But when you have
Oh.
same name, yes, you have to tell that, okay, this is from employee and use this from department. All good so far?
Yes, Swapnil.
Okay, so we have reached till here. There are a few more things I want to do, like any and all. We'll see that in the next session. And yeah, and of course we have done this. So we are almost done. Right? So yes, so we'll end it here for today. We'll see you tomorrow. We'll continue. We'll wrap up this, and then we'll move to our next topic.
Yeah, okay.
Thank you.
Thank you. Thank you so much. Yeah, have a good evening, good day, and we'll see you tomorrow.
Thank you,
Bye.
Swapnil.
Thanks, Swapnil.
Bye.
Bye.
Take care.